Hello everyone. In this session, I'll be explaining about AWS Redshift and will cover all these topics that is what it is, why we need key features, how AWS Redshift will work, use cases of AWS Redshift and pricing model of AWS Redshift, and also I'll show the demonstration of AWS Redshift, that practical session at the last. So let's move. What is AWS Redshift? It is a fully managed, scalable cloud data warehouse service provided by Amazon Web Services. It is designed to handle large volume of structured and semi-structured data, making it ideal for running complex queries and analytics on a big data. It allows user to easily store and analyze petabytes of data using its massively parallel processing architecture, which distributes queries across multiple nodes to ensure fast performance. And this service is based on a PostgreSQL, allowing user to utilize SQL for querying. Redshift supports integration with other AWS services like S3 for data storage and EC2 for computing, as well as third party BI tools, making it a powerful solution for business intelligence, data warehousing, and analytics in the cloud. So let's understand why we need AWS Redshift. So already we know that it's a powerful choice for a business looking to manage and analyze large volume of data due to its scalability, cost effectiveness, and performance. With its fully managed nature, it's eliminate the complexity of setting up, managing, and scaling a data warehouse, allowing organization to focus on insights rather than the infrastructure. Its columnar storage, parallel processing capabilities, and advanced comparison techniques provide fast query performance even on a mass data set. Additionally, Redshift integrates seamlessly with other AWS services like S3, making data loading and processing easy. The pay as you go pricing model and the ability to scale compute and storage independently to help optimize cost. These feature makes Redshift an ideal solution for business needing a flexible, high performance data warehouse in the cloud. So let's understand the key features of AWS Redshift. In this, first we have a scalable architecture. So AWS Redshift offers the ability to scale storage and a computer resources independently. This means that as data grows, you can increase the storage capacity without having to scale the compute power and vice versa. These flexibility help optimize cost and performance, allow you to adjust resources based on workload demands. So the next feature we have is a SQL query engine. Redshift uses a SQL query engine that is compatible with a PostgreSQL, which make it easy for user familiar with SQL to query data. The compatibility ensures that you can use standard SQL commands for data manipulation and retrieval along with support for complex query and analytics. The third feature we have is it is a high performance, is driven by its columnar storage architecture, which stores data by columns instead of rows. These allow for more efficient reading of large data set, especially when querying specific columns. Additionally, data compression techniques are employed to reduce storage requirements and further enhance query performance. And the fourth feature we have is a data sharing. Redshift provides secure data sharing capabilities across AWS accounts and regions, allowing organization to collaborate by sharing data sets without needing to replicate the data. These ensure that the multiple user or applications can access the same data while maintaining data security and integrity. The fifth feature we have is a integration. Redshift seamlessly integrated with a wide range of AWS services such as Amazon S3 for storage, Amazon EC2 for computing, and Amazon AWS Glue for ETL operation. It also supports popular business intelligent tools like Tableau, Locker, and a Power BI, allowing user to easily visualize and analyze data stored in a Redshift. So these all key features make AWS Redshift a comprehensive and effective data warehouse solution for organizations looking to perform large scale data analysis in the cloud. So let's understand how the Redshift will work. First thing here we have is a cluster. That means they already told it's a collection of nodes for processing. So AWS Redshift operates through a collection of nodes that are grouped together in a cluster. A cluster is the fundamental unit of Redshift that handles data storage, processing, and querying. Each cluster consisting of multiple nodes allow Redshift to scale horizontal by adding more nodes as needed to handle large workloads and data volumes. So the next we have is a leader node. So the leader node is responsible for coordinating queries across the cluster. It manages the metadata, keeps track of the query, execution plan, and decides how to distribute the query workload across the compute node. So the leader node aggregates result from the compute node and sends the final output back to the client. It also manages connection and monitor the cluster health and performance. So the next we have is a compute node. Compute node are the workhorses of the Red House cluster. They perform the actual query execution, retrieve and process the data, and store the data in a distributed manner. Each compute node has a local storage where it keeps part of the data and processes queries in a parallel with other compute nodes, improving performance. These nodes are responsible for carrying out the heavy lifted of query computing and data processing. And it's a columnar storage. AWS Redshift uses columnar storage which organize data by columns rather than a rows. These allow Redshift to ready only the necessary columns needed for a query, which significantly speed up query performance, especially when working with the large data set. The columnar format also for better data compression, reducing the storage cost and improving query efficiency. Together, these components works to deliver a high performance, scalable and efficient data warehousing solution, enabling fast processing and analyzing of large volumes of data. So this is how the Redshift will work. I'll show it in a practical session at the last. So let's understand the use cases of AWS Redshift. So the first use case we have is a data warehousing. AWS Redshift is primarily used as a data warehouse solution where organizations store large volume of structured data. It allows companies to consolidate data from various sources such as a transactional database, third party services, or a IoT devices into a single centralized repository. Redshift provides fast query performance and a scalability, making it ideal for business that need to process and analyze vast amount of data for reporting and a decision making. So the next we have is a business intelligence. Redshift is widely used to support business intelligence tools like Tableau, Locker, and a Power BI by storing data in a highly efficient columnar format. Redshift enable fast querying which allow BI tools to deliver real-time insights. These tools can connect to Redshift to create dashboards, visualization and reports that help business user analyze trends, track key metrics and makes data driven decision. So the next use case we have is analytics on large data sets. Redshift is designed to handle big data analytics, which make it a strong choice for organization. Working with large data set is capable of running complex analytical querying across petabytes of data. This is particularly useful for industries like finance, retail, and healthcare, where large volume of data needs to be processed quickly to extract valuable insight, trends, and pattern for the strategic planning. So the next use case we have is a log analysis. Redshift is also commonly used for analysis logging from various sources such as web servers, applications, or a cloud infrastructure. By ingesting log data into Redshift, organization can run complex queries to monitor system performance, troubleshoot issue, track user behaviors, and improve security by identifying patterns or anomalies. With Redshift ability to scale and query large data set efficiently, business can gain actionable insights from log files in a near real time. So these use cases highlights Redshift versatility and ability to handle a varieties of data processing and analysis needs across different industries. So the next topic we have are benefits. So the first benefits we have is cost effective on-demand pricing. So AWS Redshift offers a pay as you go pricing model, which means you only pay for the resource you actually use without upfront cost. This is ideal for business that needs flexibility and want to avoid large capital expenditures. Redshift also provide reserved instance pricing, which can offer significant saving for long-term usage. These cost efficiency make it a popular choice for organization all size for startups to large enterprises. So the next we have is a scalability for growing dataset. One of the major benefits of AWS Redshift is its ability to scale both storage and compute resources independently as your data grows. You can scale your Redshift cluster by adding more nodes to handle the increased workloads. This scalability ensures that the Redshift can efficiently manage and process vast amount of data, adapting to your business needs as they have evolved. Easy integration with data storage. It integrates seamlessly with a wide varieties of data sources such as Amazon S3, Amazon DynamoDB, and external databases. These make it easy to load and query data from different sources. Redshift Spectrum further extended its capability by allow you to run queries on data stored in Amazon S3 without needing to handle it into the data warehouse. Additionally, Redshift supports integration with popular BI tools like Power BI and a Locker enable data easy data analysis and a visualization. Simplified management for backup and monitoring. It simplifies many aspects of data warehouse management. It automatically handles backup, allow you to restore data from snapshots, which ensure data durability and protection. It also provides built-in monitoring tools such as AWS CloudWatch, which lets you track cluster health, query performance, and resource utilization in a real time. These management features reduce the operational burden on IT teams, allow them to focus on more strategic. So these benefits make AWS Redshift an attractive choice for business looking to leverage cost-based data warehousing for big data analytics while optimizing cost and minimizing the management overhead. So these benefits make AWS Redshift fully managed. So pricing model. So when it's come to its pricing model, first we can see that it's a on-demand pricing. That means pay as you go procedure. With on demand pricing, you pay only for the resource you use without committing to long term contracts. This model is ideal for business that have fluctuating workloads or a temporary data warehousing needs. You can choose different instance type based on the required performance and storage, and you are billed hourly based on your usage. These flexibility make it easier to manage cost and scales as needed. Reserved instance, that is long term saving. It provides significant cost saving for business that know they will use AWS Redshift for an expanded period. By committing a 1 year or a 3 year term, you can receive a discount up to 75% compared to on-demand pricing. Reserve instance came with the fixed cost structure, and the longer the commit, the larger the discount. This model is beneficial for organization with steady predictable workloads that needs guarantee capability over a long period. And we have a concurrency scaling, so it's help manage periods of high demand or a concurrent query by automatically adding additional compute resources when needed. So these features enable that performance remain consistent during spike in workload, such as during business reporting time. You only pay for extra capacity when it's needed. Use it, which helps optimize cost. The benefits of concurrency scaling is that it provides the flexibility to handle unpredictable query loads without over provisioning resource continuously. So these pricing options offer flexibility, scalabilities, and a cost efficiency, allowing business to choose the best model that aligns with the needs and the budgets. So these are the topics of AWS Redshift. I'll cover that all in the theoretical part. So let's move to the practical session, and I'll show the demonstration of AWS Redshift. So let's go to the AWS account. So in the search bar, type for the Redshift. So Amazon Redshift. So go to the Amazon Redshift. So see, they only said that it's a fast, fully managed petabyte scale cloud data warehouse, and it makes easier for you to run and scale analytics without having to manage your data warehouse. So, and it's a get insights from data in a seconds without managing data warehouse infrastructure. First time, Redshift serverless customer receives a dollar 300 credential to use their account. So, in this, go to the cluster. So, before creating a cluster, we have to create a subnets group. So, scroll down, you can see a subnets group. So, under the configuration, you can see the subnets. So, why we need to create this subnet? Because a subnet group defines a set of subnets which your VPCs that are used to deploy your Redshift cluster. So these subnets are in a different availability zone to ensure high availability and fault tolerance. So why it needed network isolation? A subnet group ensure that your Redshift cluster is deployed in a specific subnets, allow you to control network traffic and ensure proper isolations with your VPCs. So by distributing your Redshift nodes across the multiple availability zone within the subnet group, you improve the fault tolerance and the availability of your cluster. If one availability zone fails, the other availability zone can be continue operating. By using a subnet group, you ensure that your Redshift cluster is only accessible from your VPC or connected network, protecting it from a external exposure. So that's why we need to create a cluster group. So click on. So already I have created one cluster group. So I'll show you how to create those things. So click on create. So here you need to give the name. So the name already taken, that a cluster subnets group. So and you need to give the description. I'm giving the same description. So let's add subnet. So here we need to add a VPC. So here I'm taking a default VPC, and here you need to add a availability zone. So here you have three availability zone. So I'm using this, and subnet. So add subnet. Here we have created a subnet in this cluster subnet group 1 we have created, and you can create another subnets also here. So click on add subnet, and after this you can click on create a subnet group. So this will create your this subnet group. So after creating this, what we need to do is, so let's go to the cluster. Let's create a cluster. So click on create cluster. So now we need to create a cluster. Why we need to create a cluster in this? Because a Redshift cluster is the main data warehouse environment where your data is stored, processed, and queried, and consisting of one or more nodes, including a leader node that for managing query coordination, and compute node state data and process queries. So why it needed? Data storage and processing. Redshift clusters are where your data resides and it proceeds. Each cluster provides the compute resource necessary to run SQL queries, store large data set, and perform analytical on them. So clusters can scale horizontal by adding more nodes to increase compute power or storage capacity as your data grows. Redshift clusters are designed for high availability. The use of multiple nodes and availability zones ensure the data is available even if there is a failure or one node of the nodes in a or a viability zones. So that's why we need a cluster. So, so the cluster name Redshift cluster 1, and the node type here we need to change. See, the per hour it's charger for 3.28 per node per hour. So RA3 large also 0.569. So let's check for the low price. So see, DC2 dot larger, it's a storage 160 GB per node, and per hour it charges for $0.2 something. So select on that. So uh, so for the number of nodes, so for the demonstration purpose select only for the one node, and see the configuration summary D2 one node. So 160 GB per month, $208 something it's can charges. So enable the load sample data your Redshift clusters to start using a query editor to query data. So, ticket as the sample data set, the use of sample data set called ticket. Ticket contain individual sample files to fact tables and a 5 dimension. I'll show you. So, here a data configuration. Here you need to set the username, admin username. It should be in a lower case, and admin password, a manage admin credential in AWS Secret Manager. No, I don't want. Generate a password means they only generate a password for you, or you can click on create a manage, add the admin password. So give the password, and cluster encryption. Here I'm disabling the cluster encryption, and so here we need to create a IMA role. So if you want to create IMA role, you can create IMA role here direct only, or else what you want to do is go to IAM. Here already I have created the role for the Redshift. When you go to rules, so So no. So okay, let's create a role for this. So click on create role and select here redshift use case and click on next, and here search for AWS Redshift, or else when you go here, so they only told that you need a Amazon command full access role. So type for that only Amazon Redshift. See, Amazon Redshift all command full access. That only they have told, right? Amazon Redshift all command full access. So select this and click on next. So here a role name. We need to give a role name. So here I am giving the AWS Redshift. And the description, allow Redshift cluster to call AWS services on your behalf. So the permission we have given, click on create role. So this will create a role for us. So let's, yeah, it has been created now. The role has been created. So now what we need to do is we need to associate the IMA role for this. So when you click so we need to refresh this page and we need to enter all the commands once again. So just refresh the page. So type node, I have taken a D2 larger and the number of nodes should be 1, and click on sample data, and we need to give the name Redshift admin, and we need to manually give the password. So disable the cluster encryption, I want that. So and when you go to the association of IAM, see that we have created the, just click on that and associate IAM role, and it's not necessary, so I'm removing this role. So as I have created the AWS Redshift. So when you additional configuration, when you disable this, so go to the network security. So here the virtual private cloud is default private cloud, and here we need to create a security. So in the default security only, once again I'll show you another thing. Mm, so as this is my default security group, so in this what I have done is, so I have given the permission for Redshift and the port number. For that, what you need to do is, so go inside the security groups and edit inbound role. So here, what you need to do is, so click on add role and select for the Redshift, and it automatically take the port number and custom that we are sending that anywhere from, and save the rules. So this is what I have taken there. think I need to do it from the beginning. Sorry. I think I have done correct, right? So Redshift cluster 1, DC larger. Okay. Node 1 I have taken. Check. I've given the password and disable the configuration. Okay. So in this, the network and security. So we need to select for the default, and we need to select for the availability zone. So and the rest of the thing will be same, and the database development already taken, and the port number that I have shown you under the maintenance. So, so once you're creating those things, you can go through all the settings and check for that. So click on create cluster. So it will create a cluster for us. So it's showing not valid. Okay. So it will creating. I have created one node. So it's took sometimes. So let's wait for this. I'll be back once it available. So as it is available now. Now what we need to do is, so click on this cluster. So it's available and the number of service we have taken here. Hmm. So here in query data, click on query in a query data editor v2. So it will open a database for us. So here what we need to do is, so here the Redshift cluster one has been came. So in this go to native database. So here they have given us a sample database. So they have given sample database for us. So let's open a sample notebook. So click on yes, you do the sample database. Do you want to create sample database for us? Yes, click on create. So let's wait it open a sample database for us. So let's wait few minutes. So until that we can see here we have queries, notebooks, charts, and the history what we have done, and schedule query. If you go to create, so here you have databases, scheme, tables, and functions. You can do that, and you have load function. So here we have some sample databases. So we have some sample databases right here. So yes. So just click on a run here. So see the run status will showing cell running in the progress. So the data has been shown. So they have taken sales for date. In this date, the sum of number will be shown. If we change the number for 8 or anything and run again, it will change the number that what expected. So this is how the AWS Redshift will work. Uh, so you can, well, your demonstration, you can go through all the services here we have. As of now, that's it. So when you go here, so this is the things action. So we can pause this also, or we can directly delete it, those things. So as you know that it's not a free of cost. After creating all those things, try to delete, don't forget. So if you forgot, you can incur the charges. So click on delete. So here when you delete the Redshift cluster, they ask for you want a final snapshot or you want. So no, uncheck this and give the confirmation of delete cluster. So this will delete a cluster for us. See, it is in a modifying deleted stage. It's still in a modification only. It took some time. So that's all about the practical session of AWS Redshift. So don't forget to delete the created resources at the last because it's incurs the charges for us only. So try to delete those things after creations. So thank you.